Hello and welcome to our second lesson as we look at two variable data in chapter 4 here. We're going to talk about what we're calling real world slopes. What a real world thing is for a math teacher is very different than the real world. We're just going to make them word problems. So if you see real world, a lot of times that just means we're going to do some word problems. So there's some application. We should think about what the situation is. And then slopes are going to be these changes that we see. So when we talk about two variable data, what we have is one variable that we call independent variable is affected, and that necessarily will affect the y variable or dependent. So we'll be oftentimes using x and y, but you can use time and your pay or time and distance. So here we go. For our rate of change, we're now going to finally call that a slope. That's kind of the math term. And what we get, how we get that is we look at the rise over run of a line. When you look at something like this, the rise and then the run, whoops, to get to like what we call a lattice point here, this rise over run has to equal this rise over run, has to equal every little rise over run. That number has to be the same or constant, which is different than a horizontal line where it just always equals the rise is 0. So horizontal line, a left-right line like this, has a rise of 0, run of everything. This one has a rise of some number divided by a run of a number that keeps the slope constant. Anyway, changing y over changing x is a way we can calculate that. So in this situation, it's going to work out okay. We've got numbers we can label as a y1 or y2, x1 or x2. All right. When we think about the y-axis, again, this is going to be our dependent variable. And this one's going to be our independent. So what we'd say is, like, for instance, let's say you get paid $10 an hour. If I said, how much money do you make? A good answer would be, it depends. And what does it depend on? It depends on how many hours you work. So if you make a constant rate of pay, like $10 an hour, I can work 1 hour, I can work 7 hours, I can work 2.4 hours. I just use my constant rate by multiplying the slope times the time, or the rate times the time. And then real quickly here, a positive slope, reading from left to right, it goes up. So it's positive slope, it'll be a positive number. A negative slope is a negative number. And as x gets bigger, or we go from left to right, we're multiplying by a negative number, and it's going to go down. A zero slope is a slope of 0. Okay. And then undefined is going to be a vertical line. I had a student that said he had a teacher that used to say Vux Hoy. I'm going to talk about this just real quick. Vux Hoy. And that was a way for a kid to remember a vertical line has an undefined slope, and it is an x equals equation. Those are kind of hard. That doesn't have to be x equals 0 though, but in general, x equals a number. And then H in this Hoy is horizontal, so that's a left and right line, that's this guy, and has a slope of 0, and then it's y equals some number. We don't know what it is, but it won't have a changing value. It'll just be a constant number. So Vux Hoy, something to think about. Calculate the rate of change, so or slope, for this. And we want to use units. And we're going to use what's called a unit rate also. Unit meaning just what per one. So if I looked at these, I could do, like I pointed out here, a lot of different points in using them. But what I'm going to do is I'm going to label this point here as x1 and y1. And this is x2 and y2. And then I'm going to use my slope formula. I don't know if we've used this much this year, but it's something that you probably saw when you did linear equations last year. And that is, oops, change in y over change in x. That changes the subtraction. So if I were calculating this, I've labeled this as y1, so 80 minus, no, y2 is what I want to plug in there. Ultimately, it only matters that we keep our pairs together here, but so 160 minus 80 divided by 12 minus 4, and that equals 80 divided by 8. And we could say that the slope is 80 over 8. We typically like to simplify things, but it's very useful. If I say I go 80 miles per 8 hours, and then I have another situation where I go 120 miles per 12 hours, it's hard to tell that they are the same rate, in this case, 10 miles per hour, or you could write it as MI, miles divided by hours. But MPH is pretty common in our world. And then now I'm going to look at a word problem. A gardener measures the height of a plant at 2 different times. So right away, I'm thinking I'm going to have 2 ordered pairs, an independent and dependent variable. The first one occurs at 2. I have a 4 centimeter tall plant. And then at 6 weeks, that's time is our x coordinate here, it reaches 12. And one of the things you want to do in word problems, and I'll try to point it out, but you want to ask yourself, what depends on what? Does the time depend on how tall something is, or does how tall something is depend on how long it's been growing? So the dependent variable, in this case, the height, 4, depends on how many weeks it's been growing. If someone asks how tall is the plant, you could say it depends, and the answer is it depends on how long it's been growing. Okay, so I'm going to kind of cruise through this stuff. One of the ways I do this is this is my y2, 12 minus 4, and that's 8, divided by 6 minus 2, that's 4, and I get 2, and in units, that is centimeters. Remember, I said MPH over here, miles per hour. This is centimeters per week. And then real quickly, I want to show you that if you chose your points to be different and you actually went in the opposite order, so I'm going to go 4 minus 8, because it's very possible 2 people can look at these points and call them a first or a second in a different order. And this is 2 minus 6. You'll notice I get 4 minus 8. Well, that's not the same. Sorry, 4 minus 8. How about I use the number 12, since that's what it is. 12. That is negative 8. But we had positive 8 up here. It looks like we might have a problem, but if you do 2 minus 6, you get negative 4. Negative over negative cancels out, and I still get 2 centimeters per week. Okay, so identifying the x and the y is very important. Which one you call the first or second point won't affect this answer. All right, let's do some classwork here. Be prepared to listen to this again. I'm going to try to move quickly so I don't have a 20-minute video again. Rate of change or slope, rise over run. I'm going to do a full deal here. I'm going to give you the equation. An equation for our linear relationships is y equals mx plus b. B is the y-intercept, and m is the slope or rate of change. And looking at this, the y-intercept, the value of y when x is 0. We did that in our last lesson. Here's x is 0, and the value is y. So I'm going to have y equals something x plus, in this case, 200. And then my rise over run is rise of 100, run of 5, rise of 100, run of 5. I could write these as points, 0, 200, 5, 300. And what I get is 100 divided by 5, well, that reduces to 20. So we would say that the catering fees have a cost per person of $20. So it's $20 per one person, and $200 they must charge you for a setup or something. Okay, why don't you try this one? I'm going to run this out as well. The question says, find and interpret the rate of change. I guess I didn't quite do that. So this one has a rate of $20 per person, and it has a starting value of $200. So it must cost $200 to get the setup and then start paying $20 per person. I'm going to do the same thing here, but the actual question will just be the slope. So the plant growth, kind of tough to tell what's happening down here, okay? But I've got these 2 points. I'm going to do 20 minus 10, so my M is 20 minus 10, and my divided by 50 minus 30, and that reduces to 1/2. So to answer this question, the slope is 1/2 centimeters per day, okay? And if I were going to write, I guess I'm going to try to move along here, but it's going to take a little bit of time here to figure out what that y-intercept is. It's falling off the graph here, but if I look at this, if it changes by 1/2 centimeter per day and I'm at 10 centimeters here, it looks like it will just lower down to -5. Maybe I'll do this anyway. This is not part of the lesson. This part is right here, saying 1/2 centimeter per day. That's the answer. But I'm giving you a little free extra knowledge. Okay, so I did this. This -5 might be kind of hard to figure out, but in 10 days of growing by 1/2 centimeter, it must have started down 5 centimeters in the ground. Toy race car, got some numbers here. So I'm going to start again with my M. I'm going to do 21 minus 13, and I'm going to do 4 minus 2. That is a unit value of 4. And so I'll just maybe get a bit lazy now right here. 4, and my units are feet per second. Okay, so there's my answer here. To write the equation, it's not too hard. 4x plus 5. If I interpret that right. Okay, so the question was find the rate, give the context, basically give the units, but I'm giving you a little freebie on finding an equation in slope-intercept form. All right. Some more problems. I want to find the same information here. So I'll go ahead and just write M equals and B equals. And then I'll give you an equation as well. I may not for these. This one, this one I can do, but this one's a bit of a hassle. All right, so I have a y-intercept of 0 here, obviously. And it has a change from here to here, rise over run. I can just count 2, 4, 6, and over 1. So my M is 6 over 1, and to use units, it's going to be feet per minute. And my equation would be y equals 6x plus 0. And you wouldn't need to put the 0 there. In this one, I'm going to have to get a calculator out, but I'm going to pick a couple of numbers here. I mentioned previously that, so if we just count these changes and divide them into what the changes are for the y, the rise, every time I do this change divided by this change, it should be the same as any other point. Otherwise, my rate would look like this, and then change, and then change, and then change. It should be a constant rate of change and make it a straight line, not a disjointed one. So I can choose any of these points. I'd encourage you to look into that. Like I'm going to choose the points. I'll just use this one. I'll call this one x1, this one y1, this is x2, this is y2. But if you ran through and did your numbers with these 2 points in the middle here, or this point and this point, you could do that. You better get the same M or rate of change, otherwise it hasn't, it's not a straight line. Okay, so working on this, I'm going to get my calculator. And what I got is 32,400 divided by 1440. And then when I simplify to what's called, again, a unit rate, I get 22.5. So what does this mean in the context of the problem, 22.5? It is the y units divided by the x units. So this means you're paying $22.50. So this is dollars per ticket. That's pretty meaningful. I paid $22.50 per ticket. I'm not going to do the B on this, but what I could do, like in the other one, is find out what 160 tickets cost. Well, I guess that's this one. But work backwards from there. 2250 times 160 is some number, and then there might have been a setup fee. So this one I'm going to wimp out and not give you the whole equation. I will swing over here. This one is a good one to do completely. We're going to take, this is a really good example to put a star by it and make it one that you study from, because this one's got a couple things going on I want to show you. It's got numbers I don't really like with decimals, but we're going to figure out the y-intercept on this one. So again, it doesn't matter which 2 points, because every change in y over change in x, no matter where you go, if I go from this point to this point, or if I go from this point to that point, whatever it is, that I'm going to have a constant rate of change if it's linear. So I'm just going to pick, I'll just pick the first two. And I'm going to do 46.4 minus 51.4. So 46.4 minus 51, I'm sorry, 51.2. And I get negative 4.8. And then divided by 4 minus 2. 4 minus 2 is positive 2. And notice I get a negative 2.4. And the units would be gallons per hour. So in the context of this problem, what does that mean? Well, it means you got a pool that after 2 hours of draining, it's got 51.2 gallons, and then 2 hours later, it's down to 46.4, and another 6 hours to here. We could do this one all the way down to what we call the x-intercept. We want to see how long it takes to drain completely. That would be something we could try to solve for. I'm going to work the other way because it's a little easy. If it's been 2 hours and it's losing 2.4 gallons every hour, or I could say 4.8 gallons every 2 hours, I can figure out what the y-intercept, the value of y when x is 0, that's my starting amount. How many gallons were in this pool? And I can do that by doing, instead of subtracting, for each of these I was subtracting 4.8, but I did get my unit rate. This one I like. I'm going to add, because I had to have an extra 4.8 gallons to get down to here if it lost 4.8 gallons every 2 hours. Anyway, I add in that 4.8. Looks like it's a, oops, 50. Oops, all right. So if I add the 0.8 to that, it's 52, another 4, so 56 gallons. It started with 56 gallons. I'm going to go ahead and write the equation then. Negative 2.4x plus 56. If I wanted to find out what the starting value was, it's the value of y when x is 0. If I plugged in the 0 there, I'd get a y of 56. That's my y-intercept, my starting amount or initial amount. It's losing 2.4 gallons every hour, even though I've been keeping track every 2 hours, losing 4.8. All right, trying to move along here. Cyclists travel 60 miles or kilometers in 30 hours. Well, that one, they did the work for us. I don't know where they started or stopped. I know the change in y is 60 and the change in x was 3. I'll try to explain this a little bit. Again, how do we know which one's the x or the y? It's not always obvious. Does a cyclist's position, how many kilometers they've gone, depend on how long they've been riding? Or does the time depend on how far they end up? And these are things you're going to want to practice. I simplify this to the unit rate of 60 kilometers per hour. I'm not going to do the equations on these. We won't practice our rates. A car's value decreases from 20 to 12,000, and it takes 4 years for that to happen. Well, the time at initially 0 years was 20 grand, and then 4 years later it's moved down $8,000, and it's taken 4 years. 8 divided by 4 is 2, so that's a negative $2,000 per year. And what this means is a car is losing its value every year. It loses. It's kind of like when you buy something new and then over time it loses value or it becomes of less value. So down $2,000 per year. Temperature at 8 a.m. is 10 Celsius, and at noon it's up to 22. Well, it's gone up 22 minus 10, 12 degrees in 4 hours. 8 a.m. to noon is 4. So we would say this is 3 degrees per hour. The temperature is going up. DJ has $500 in the bank account. Well, that sure sounds like a starting value. I think that's going to be my B. But anyway, after 2 months, and then, after 2 months, never mind. That is definitely not DJ's money at the beginning. That's his money later. So I have 2 months, $500, and 5 months, $1,200. So my M, the thing I'm trying to find, my rate of change, is going to be 1,200 minus 500, 700. 5 minus 2 is 3. So that's a good sign. At least his money's going up. And then to be able to write this as a unit rate, I get 233.33. And that means, on average, he's investing or saving $233.33. Notice when you do the number here, it's repeating 3 all the way to here. I stopped at 2 places. There's a reason for that. This is a word problem with context. The smallest values we would go to is pennies. So I stopped here. I could have written more. I could have rounded to the nearest dollar. That would have been reasonable as well. But you want to make sure you pay attention to what the context is. So this was $233 per month. All right, ready for some homework, and we'll see you in class.